Imagine walking along a beach, a place you associate with life, with beauty, with the vibrant energy of the ocean, and finding it littered with the bodies of dead whales, dolphins, and seals. Their eyes are vacant, their bodies bloated or emaciated. Picture once thriving coral reefs, vibrant ecosystems teeming with colorful fish, now bleached white, ghostly skeletons of their former selves. Seabirds washing ashore weak, starving, their feathers coated in oil or their stomachs filled with plastic. These aren't scenes from a post-apocalyptic movie or a dystopian future. These are real events, documented events, happening now, with increasing frequency, in oceans around the world. Something is killing marine life on a massive scale, and the reports are coming in from all corners of the globe. Is it a single, unifying cause? A series of unrelated events? Or are we witnessing a complex interplay of factors, a synergistic assault on the delicate balance of our oceans? And most importantly, what can be done to stop it? Let's investigate, separating fact from speculation, and examining the evidence. Our oceans, the lifeblood of our planet, are sending out distress signals. We're not just talking about gradual, long-term decline. We're talking about sudden, catastrophic events, mass die-offs of marine life, happening with alarming frequency around the globe. This video isn't about assigning blame or pushing a specific agenda. It's about examining the evidence. It's about understanding the multiple, interconnected threats facing our oceans, and asking the crucial questions: what's really killing our sea animals? Is it one single factor, or a deadly combination? And most importantly, what, if anything, can we do about it before it's too late? We'll explore real-world examples, cutting-edge scientific research, and the uncomfortable truths we need to face to protect the future of our oceans. One of the most pervasive and insidious threats to marine life is pollution. It's a silent killer, often invisible to the naked eye, but its effects are devastating. And it's not just one type of pollution, it's a complex mixture of substances and materials that are entering our oceans from a variety of sources. Plastic pollution is perhaps the most visible and well-known form. Millions of tons of plastic waste end up in the ocean every year, ranging from large pieces of debris, like fishing nets and plastic bags, to microscopic microplastics. Marine animals can become entangled in this plastic, leading to drowning, injury, and starvation. They can also ingest plastic, mistaking it for food, which can block their digestive systems, leach toxic chemicals, and lead to malnutrition. And it's not just the large animals. Even tiny plankton are consuming microplastics, introducing these pollutants into the base of the food web. The Great Pacific Garbage Patch, a swirling gyre of plastic debris in the North Pacific, is a stark reminder of the scale of this problem. But plastic is just one piece of the puzzle. Chemical pollution is another major, and often invisible, threat. Industrial waste, agricultural runoff, and sewage discharge can introduce a cocktail of harmful chemicals into the ocean, including heavy metals, like mercury, lead, and cadmium, persistent organic pollutants (POPs), like PCBs and DDT, pesticides, herbicides, and fertilizers. These chemicals can be directly toxic to marine life, causing poisoning, reproductive problems, developmental abnormalities, and immune system suppression. They can also bioaccumulate in the food chain, meaning that the concentration of toxins increases as you move up the food chain, with top predators like tuna, sharks, and marine mammals being particularly affected. Nutrient pollution, particularly nitrogen and phosphorus from agricultural fertilizers and sewage, can cause another devastating problem: harmful algal blooms, HABs, also known as red tides. These blooms occur when certain types of algae, often microscopic phytoplankton, grow rapidly and out of control, fueled by an excess of nutrients. Some of these algae produce potent toxins that can kill fish, shellfish, marine mammals, and seabirds, and can even cause respiratory problems and neurological damage in humans. Even non-toxic algal blooms can be harmful, as they can deplete the oxygen in the water when they die and decompose, creating dead zones where marine life cannot survive. These dead zones, often found near the mouths of major rivers that carry agricultural runoff, can be vast, covering thousands of square miles. Oil spills, while often dramatic and highly publicized, are actually a smaller contributor to overall chemical pollution than chronic, low-level inputs from land-based sources. However, oil spills can have devastating localized impacts, particularly on sensitive ecosystems like coastal wetlands, mangrove forests, and coral reefs. Even small amounts of oil can be toxic to marine life, damaging the feathers of seabirds, the fur of marine mammals, and the gills of fish, disrupting their ability to regulate their body temperature, swim, or breathe. Oil can also smother coral reefs and other benthic, bottom-dwelling organisms. The long-term effects of oil spills can persist for decades, as oil residues can remain in sediments and continue to release toxic compounds. Climate change isn't just a future threat, it's a present reality, and it's already having profound impacts on our oceans. It's acting as a threat multiplier, exacerbating many of the existing problems facing marine life and creating new ones. Rising ocean temperatures are one of the most significant and widespread effects. Many marine species, from tiny plankton to giant whales, are adapted to specific temperature ranges. Even small changes in temperature can disrupt their physiology, behavior, feeding patterns, and reproduction. Corals are particularly vulnerable to warming waters. Coral bleaching, a phenomenon where corals expel the symbiotic algae, zooxanthellae, that live within their tissues and provide them with food and color, is a direct result of rising ocean temperatures. When water temperatures are too high for too long, the corals become stressed and expel the algae, turning white bleached. Bleached corals are more vulnerable to disease and death, and if the stress is prolonged, they can die off completely. Widespread coral bleaching events, often triggered by marine heatwaves, are becoming more frequent and more severe, threatening the survival of entire reef ecosystems, which are biodiversity hotspots and provide crucial habitat for countless marine species. Ocean acidification is another major, and often overlooked, consequence of climate change. As the ocean absorbs excess carbon dioxide (CO2) from the atmosphere, primarily from the burning of fossil fuels, it becomes more acidic. This increased acidity reduces the availability of carbonate ions, which are essential building blocks for the shells and skeletons of many marine organisms, including corals, shellfish, oysters, clams, mussels, pteropods, tiny sea snails that are a crucial part of the marine food web, and some types of phytoplankton. This makes it more difficult for these organisms to build and maintain their shells, making them more vulnerable to predators and disease, and potentially disrupting the entire food chain. Changes in ocean currents, driven by changes in temperature, salinity, and wind patterns, are also having significant impacts on marine ecosystems. Ocean currents play a crucial role in distributing heat around the globe, influencing weather patterns, and transporting nutrients and larvae. Changes in these currents can alter the distribution of marine species, disrupt migration patterns, affect the availability of food, and change the upwelling of nutrients from deeper waters, which is essential for phytoplankton growth and the base of the marine food web. We're already seeing evidence of shifts in the distribution of some fish stocks, which can have significant economic and social consequences for fishing communities. Disease outbreaks are another significant cause of mass mortality events in marine life, and these outbreaks can be exacerbated by other stressors, such as pollution, climate change, and habitat destruction. Marine animals, like terrestrial animals, are susceptible to a variety of diseases, caused by viruses, bacteria, fungi, and parasites. Warmer water temperatures can increase the virulence of some pathogens, making them more deadly, and can also stress marine animals, making them more vulnerable to infection. For example, sea star wasting disease, a mysterious illness that has caused massive die-offs of sea stars along the Pacific coast of North America in recent years, is thought to be linked to warmer water temperatures. Similarly, outbreaks of fibropapillomatosis, a disease that causes tumors in sea turtles, have been linked to pollution and environmental stressors. And coral diseases, such as black band disease and white band disease, are becoming more prevalent as ocean temperatures rise and coral reefs are weakened by bleaching and other threats. Harmful algal blooms, HABs, also known as red tides, although they can be many different colors, are another major threat to marine life, and their frequency and intensity appear to be increasing in some areas. These blooms are caused by the rapid growth and accumulation of certain types of algae, often microscopic phytoplankton, that produce potent toxins. These toxins can accumulate in shellfish and other marine animals, making them poisonous to humans and other animals that consume them. HABs can also cause massive fish kills, either by directly poisoning the fish or by depleting the oxygen in the water when the algae die and decompose, creating dead zones. The causes of HABs are complex and not fully understood, but they are often linked to nutrient pollution, excess nitrogen and phosphorus from agricultural runoff, sewage, and industrial discharges, warmer water temperatures, and changes in ocean currents and stratification. Coastal development and aquaculture can also contribute to HABs by altering water flow and nutrient levels. The economic impacts of HABs can be significant, affecting fisheries, tourism, and public health. Overfishing is a major, and often underestimated, threat to marine life and the overall health of our oceans. Many fish stocks around the world are overexploited, meaning that they are being fished at a rate faster than they can reproduce and replenish their populations. Some fish stocks have collapsed entirely, leading to significant ecological and economic consequences. Overfishing doesn't just affect the target species. It can also disrupt entire marine food webs, reducing biodiversity and making ecosystems more vulnerable to other stressors, like pollution and climate change. Destructive fishing practices, such as bottom trawling, dragging heavy nets across the seafloor, dynamite fishing, using explosives to kill fish, and cyanide fishing, using cyanide to stun fish for the aquarium trade, can cause significant damage to marine habitats. Bottom trawling, in particular, is incredibly destructive, destroying coral reefs, seagrass beds, and other sensitive bottom habitats that provide shelter and breeding grounds for countless marine species. Bycatch, the unintentional capture of non-target species in fishing gear, e.g., sea turtles, dolphins, seabirds, sharks, and unwanted fish species, is another major problem, resulting in the deaths of millions of marine animals every year. Beyond fishing, habitat destruction is a major threat. Coastal development, construction of ports, hotels, and residential areas, dredging, pollution, and climate change are all contributing to the loss and degradation of vital marine habitats, such as mangrove forests, seagrass beds, coral reefs, and salt marshes. These habitats provide food, shelter, and breeding grounds for a vast array of marine species, and their destruction can have cascading effects throughout the ecosystem. They also provide important ecosystem services, such as protecting coastlines from erosion and storm surge, filtering pollutants from the water, and sequestering carbon, helping to mitigate climate change. The loss of these habitats not only threatens marine life but also the livelihoods and well-being of human communities that depend on them. It is crucial to emphasize the interconnectedness of all these threats. They do not operate in isolation, they interact with and amplify each other. Climate change, for example, exacerbates the impacts of pollution, making marine animals more susceptible to disease, and increasing the frequency and intensity of harmful algal blooms. Overfishing weakens ecosystems, making them less resilient to climate change and pollution. Habitat destruction reduces biodiversity, making it harder for marine life to adapt to changing conditions. The mass die-offs we are witnessing are not just isolated incidents. They are symptoms of a larger, systemic problem, the declining health of our oceans. They are warning signs, telling us that we are pushing marine ecosystems to their limits, and that the consequences of our actions are becoming increasingly dire. The good thing is that it's still time to change. By reducing greenhouse gas emissions, we can mitigate the most harmful effects of climate change on marine ecosystems. Implementing stricter regulations on pollution and waste management can reduce the amount of harmful substances entering the ocean. Establishing marine protected areas, we can give marine life a chance to recover. Promoting sustainable fishing practices. If we all take action now, there is still hope for the future. So, what's really killing sea animals all over the world? It's not a single culprit, it's a complex interplay of human impacts, a combination of pollution, climate change, overfishing, habitat destruction, and disease, all interacting and amplifying each other. Are these mass die-offs isolated incidents, or are they a sign of a larger, more systemic crisis? Are we witnessing the unraveling of marine ecosystems, or can we still turn things around? The answer, ultimately, lies in our hands. What do you think? Are you concerned about the health of our oceans? What actions do you think we should be taking to protect marine life? Share your thoughts, your questions, and your ideas in the comments below. Let's have a respectful, informed, and constructive discussion about this critical issue. And if you found this video informative and thought-provoking, please subscribe to the channel. We'll continue to explore the complex issues facing our planet, separating fact from fiction, and bringing you the information you need to be an informed and engaged citizen. Give this video a thumbs up to show your support, share it with your friends and family, and hit that notification bell so you don't miss our next deep dive. Until next time, stay curious, stay informed, and remember, the future of our oceans, and the future of our planet, depends on the choices we make today.